So this is going to be called confidence intervals for least squares regression line. We got to do a few interim calculations before we can do the confidence interval. Let's do it. Okay. Now, you have to remember back to yesterday's lecture. I made this little drawing where I said, oh, well, here's, inputs x1, and here's all the possible outputs that it could be, and here's input x2, and here's all the possible outputs it could be, et cetera, et cetera. Here's the least squares regression line for the population. And I said that all these different outputs, all these possible outputs, would have a mean, a center, which should be right here on the regression line, and a standard deviation. And that standard deviation needs to be constant for all the outputs. Okay? So that standard deviation of the outputs also called the standard deviation of the regression line. And I like to call it standard deviations of the outputs because it kind of clues you into what we're really talking about. When I just say the regression line, it's like, okay, what do you mean the regression line? But to me, it kind of is a little more descriptive to say the output. We don't know what that population standard deviation is, but we're going to estimate it by, it's always abbreviated S, and you saw in the output from your homework last night an S written down somewhere. And this S is called the standard error of the regression line. Okay. And its formula is the square root of I take the residuals, I square each residual because I got to get rid of their signs, and then I add them all up. And then I divide by n minus 2, then I take the square root of the whole thing because it's a standard deviation rather than a variance. All right. So let's count. Yes, ma'am? Standard error of the regression line. Sorry, I wrote that small because it was kind of an aside, but okay. So let's calculate this. So the first thing you gotta do is run a linear regression so that you get the right set of residuals. So let me zoom in here. Change the lighting. Come on. Change the lighting. Just a second. Oh, I just wasn't clicking it far enough. Okay. So let's run a linear regression. So I go stat calc number 8. It was in list 1 and list 2. Boom. There's my linear regression. Now that I got a different number. Oops, typo. All right. Now that I've run my linear regression, my residual list is the residuals for this regression line. So now I want to get the sum of the residuals squared. I think I can do this in one fell swoop on my calculator. I believe I hit second stat, math, sum, number 5. I need to take the residual list. That's under second stat, number 7. And I need to square those because I got to get rid of, if I just sum them, they'd sum to 0 because they are positive and negatives. So, but if I square that, I'll get the, I'll take away their signs and square them and have to square root it back at the end. Okay. Ooh, it did work. No, you never have to close parentheses. It never require, your calculators never require you to close a parenthesis. Second stat, and it's go down your list. It's on your, it's down there somewhere. Huh?
You don't have to set the regression line as Y1.
You do not have to put in the Y1. It's saved in it's already saved in the calculator as the A and the B, and it's saved as a regression equation somewhere also. It's saved, stored someplace else in your calculator. If I look at I'll look at the vars. I'm sorry, distributions. Vars, statistics. I go over to equation. The regression equation is saved there. Well, if you ever need it again. Okay. So let me fill this into my little formula. So this is the square root of, we got 192.3 essentially, divided by n. N is the number of pairs of data that we have. Can you take a look at your lists and tell me how many pairs of data we got? So n minus 2 is 11. So my standard error of the regression line is yep. I get 4.18. I have rounded a little bit. Okay. Next, I have another standard deviation. I don't have enough room to write if I leave it zoomed out. All right. My other standard deviation I'm going to talk about is going to be the standard deviation of the slope of the regression line. And maybe I'll call that just sigma sub beta to help me remember that one. Yes, sir?
What does that say that's pointing to the X?
That says standard error of regression line. Okay? So I take the slope of all the sample regressions that I could possibly make, and I average out those slopes, and I get an average slope of the regression line for the population. And I don't know what that slope is, but there's going to be some error since it's an average. There's going to be some error, some standard deviation of that slope, and I can estimate that standard deviation of that slope with, now this is the important one, this is the SEB, and it's called the standard error of the slope. Standard error, B standing for slope, and the B is usually a sub B, sometimes it's not a sub B. And that one, the formula for that is that number S we just calculated, that estimate that we did for the standard deviation of the whole regression line, divided by the square root of